The farthest human creation drifting through the cosmos isn't just a machine, it's a silent messenger. NASA's Voyager 1 spacecraft, launched nearly half a century ago, has now pushed itself into interstellar space. Think about that. A probe built with 1970s technology, sent into the void 45 years ago, is still alive, still functioning, and still sending back signals from places no human thought it could reach. But here's where it gets truly mind-bending. This tiny spacecraft, running on computing power weaker than an old cassette player, has just made a discovery so unexpected that it stunned scientists across the globe. What exactly did Voyager 1 uncover at the edge of our solar system? And why could it reshape the way we see not only space, but our own place in it? To answer that, we have to rewind to a critical moment in space history. In the 1960s, Gary Flandreau, an engineer at NASA's Jet Propulsion Laboratory, made a stunning calculation. Using nothing more than a pencil and a slide rule, he realized that in the late 1970s, something rare would happen. The four giant planets, Jupiter, Saturn, Uranus, and Neptune, would align in a perfect arc. This cosmic alignment, appearing only once every 176 years, created a golden opportunity. If NASA could send a spacecraft at just the right time, it could use each planet's gravity as a slingshot, accelerating like a stone tied to an invisible rope. This gravity assist would cut a 30-year journey to Neptune down to only 12. NASA knew they couldn't let this chance slip away. In the summer of 1977, within just 15 days of each other, two identical probes, Voyager 1 and Voyager 2, were launched. At the time, their mission was expected to last maybe 4 years. Nobody imagined they would outlive their own designers and still be operating more than 45 years later. What followed was nothing short of legendary. The Voyager twins became the first emissaries to truly explore the outer planets. Voyager 1 and 2 flew past Jupiter and Saturn, sending back breathtaking close-ups of swirling storms, volcanic moons, and icy landscapes that nobody had ever seen. Volcanoes erupting on Io, frozen rings around Saturn, worlds that were alive and dynamic, forever changing how we thought of our solar system. Voyager 2 alone would go further than any probe before it, becoming the only spacecraft to visit Uranus in 1986 and Neptune in 1989. It revealed bizarre magnetic fields, icy surfaces, and mysterious weather systems that astonished scientists. These spacecraft, no larger than a small car, opened doors to worlds we barely knew existed, and yet their greatest journey was still ahead. By the early 2000s, Voyager 1 had traveled more than 14 billion kilometers from Earth, farther than any machine in history. To put that in perspective, its signals traveling at the speed of light take over 20 hours just to reach us. And yet, with just 69 kilobytes of memory, less than a single photo on your phone, the spacecraft kept collecting and transmitting data. It wasn't easy. The Voyagers stored information on 8-track tape recorders, then transmitted it using only 23 watts of power, less than a refrigerator light bulb. Their signals had to be captured by massive radio dishes on Earth, straining to hear whispers from across the galaxy. Crossing it should have been obvious. Scientists expected to see a sudden spike in cosmic rays, a clear shift in magnetic fields, and a drop in solar particles. But when Voyager 1 made the leap, things didn't go as predicted. Yes, the plasma density around the spacecraft suddenly spiked, confirming it had entered a new environment, but the magnetic field didn't change direction the way models had forecasted. Instead of a sharp boundary, it seemed Voyager had entered a strange transition zone, a blurry frontier where the sun's influence fades but doesn't disappear. This was a shock. The interstellar medium, once thought to be smooth and uniform, turned out to be messy, uneven, and turbulent. Voyager 1 detected plasma clouds of varying densities and temperatures, some hotter and denser, others thin and cold. These regions weren't random. They lined up with remnants of long-dead supernova explosions, as if the spacecraft was passing through ghostly fingerprints of ancient stellar catastrophes. And here's where the mystery deepens. If the magnetic fields didn't shift the way they should have, what does that mean about the boundary between our solar system and interstellar space? Is the heliopause a hard wall, or is it a fluctuating, ever-shifting veil shaped by cosmic forces we still don't understand? Some scientists believe the solar system may be wrapped in a vast, flexible transition zone. Others think interstellar space itself is far more dynamic than we ever realized. Every byte of data Voyager sends back forces us to question long-held assumptions: plasma density rising and falling, cosmic rays fluctuating, invisible forces tugging at the edges of our solar neighborhood. Instead of a calm void, interstellar space appears alive, with structures, storms, and scars carved into it by ancient stellar explosions. And all of this is being revealed by a spacecraft built with technology older than the Walkman. Today, both Voyager 1 and 2 continue their lonely journeys outward, their power supplies dwindling but not yet silent. Each day, they drift a little farther, carrying humanity's curiosity and a golden record etched with the sounds of Earth, in case some distant intelligence ever finds them. So the question remains, what other secrets lie beyond the horizon, waiting for us in the vastness between the stars? Let me know what you think in the comments. And if you found this journey through Voyager's story fascinating, don't forget to like the video, subscribe to the channel, and join us as we continue to explore the greatest mysteries of our universe.